All right, with this particular lesson, we're going to start our work with trigonometric functions. What we'll go through here is just taking what we know from triangles and now putting them into a Cartesian coordinate plane and drawing them from there, converting between degrees and radians, and then finding what's known as coterminal angles. So let's go ahead and get ourselves started. So the first one is sketch the following angles in standard form. Now, when we talk about standard form, what we mean is that we want to be able to draw this angle, for example, such that this is the initial side, and then we will draw the angle out until I get to the 60 degrees and draw my terminal side. So for me to do that, let me go ahead and change my color here. So now I'm going to use the pen to draw that, and actually I should be able to draw a line, but we'll just go through and do it by hand. So here's where we start, and we'll draw our line out. So this is my initial side. And then we're going to go through and rotate through 60 degrees. So we know roughly, and the nice thing is that this says sketch it, so we're only going to go through and sketch. So there's my initial side, and for 60 degrees it would be somewhere around here, and this rotation is 60 degrees. So what we do is we go through, we draw it out. This is our initial side every single time. We rotate through the degree measure, and we'll go 60 degrees for the first example, and this right here is what's known as theta. So theta, that's this particular symbol, theta is equal to 60 degrees. So we've just drawn in standard form where we have our initial side is a ray with the point at the vertex, our point at the origin, and then our terminal side here, and again I'll just say this is our terminal side. Our terminal side is this side right here, and again another ray with its endpoint on the origin. So I'm going to switch colors. I'm going to choose a different one. Let's go with green. All right, so now I'm going to go through and draw this angle here, alpha. So we have the same initial side. So we're going to have our initial side. And then this one says to go negative. So we're going to come down this way and rotate until we hit 135 degrees. So what I need to do then is when we deal with a negative, we're actually going to go clockwise. If we have a positive, we're going counterclockwise. So in this case, we're moving down this way. Now this right here, we know that this is a 90-degree angle. So if I rotate all the way through there, we're at negative 90 degrees. If I come all the way back for a full, like going down and through, then this is negative 180 degrees. If I continue rotating, this would be negative 270 degrees. And then if I go all the way back to the beginning, this would be negative 360 degrees. Well, I want negative 135. So what that means is that we rotate through, hit 90 degrees, and then we have another 45 degrees we have to go through. So then I draw my angle, and again, this is a rough sketch, thankfully. I'll draw that this is the way of the rotation. This is negative 135 degrees. All right, so we have two different angles that are drawn, and the whole part here is that we have one that went in a positive rotation, so it rotated counterclockwise, and that was 60 degrees. So we have our initial side, rotate until we hit the terminal side, which would be 60 degrees. We had a negative angle. Now a negative angle means instead of rotating up, we will rotate down, and we go clockwise. So negative means we rotate down. So we go 135 degrees in the negative direction. So here is 90. Then another 45 degrees gets me to 135 degrees. So this is how you would draw an angle in standard form. Next example is now we're looking at them as radians. So we have to do some work. We have to do some conversions. You should be able to go back and forth. You dealt with radians a little bit in calculations back when you dealt with geometry. So if I look at this first one, negative pi over 2. So I'm right now, or you right now, are more comfortable dealing with degrees, but eventually we have to get out of that. So now if I say I have a negative pi over 2, well, I have to multiply by the conversion factor. So when we go through and talk about our conversion, it's going to be pi over 180, and that is our conversion. Now, what this means is that my radians are on top and degrees are on the bottom. So just like we did conversions before, I have to make sure that my radians are opposite each other, my degrees are opposite each other. Now, if I want this in degrees, then that means that the 180 has to be in the numerator and the pi has to be in the denominator. So now the pi and the pi divide out to 1. And I have 180 divided by 2. So this is negative 90 degrees. Well, we know where that is. So negative 90 degrees from the work that we've done rotates down to here. So that means then here's my initial side. Here's my terminal side. And yes, it's negative 90 degrees, but that's not what I'm asked to graph. I'm asked to graph this. So I'm using the 90 degrees, the negative 90 degrees, kind of as a reference so I can go ahead and draw my angle in radians. So this means this is a rotation of negative pi over 2 radians. So now let's choose a different color here. All right, so now I'm dealing with 5 pi over 6. Well, I have to multiply 5 pi over 6 in such a manner that I can convert it for now, because I'm not fully comfortable as to where I am. And I can do that, and I'll put 180 here and pi here. So then the pi's go away. 6 divides into 180. That gives me 30 degrees. So this would be 150 degrees. Now, another thing that I want to do is talk about this in the terms of radians. So I can go through and I can draw 150 degrees, which is fine. I know it's going to be over here. Again, this is quadrant 1. Quadrant 1 goes from 0 to 90. This is quadrant 2. Quadrant 2 goes from 90 to 180. Quadrant 3. Quadrant 4. So by looking at 5 pi over 6, it will eventually become easier for you to keep this in radians. So if I look at this, remembering that if I look at it in the sense of a radian measure, right? This is 0 radians. 90 degrees, we know that's pi over 2. So every 90 degrees is a pi over 2. So if I go another pi over 2, that brings this to pi. If I go another pi over 2, that brings this to a 3 pi over 2. So now this is the radian conversion of 90 degrees, 180 degrees, 270 degrees. And then if I make my whole rotation all the way around, which would be a 360 degree revolution, that's 2 pi. Now all of this is in the notes, in the lesson notes that we've gone through. So now if I'm just looking at these yellow numbers, well, let's see, I want to go 5 pi over 6. Well, this is pi. Another way to write pi in sixths is that this would be 6 pi over 6. All right, so that means that I am 1 pi over 6 short. All right, well, pi over 6. All right, using the conversions that we know from geometry and the same thing that we did over here, using the conversions, pi over 6 means I am 30 degrees short of getting here. All right, so I'm 30 degrees short of hitting the pi over 6, because we said we're pi over 6 short of getting all the way to here. So that means I'm going to rotate 5 pi over 6. So I'm going to draw my terminal side here. I'm pi over 6 short, which we said was 30 degrees. We also said that this was 150 degrees. Remember, a whole rotation to here gets me to 180 degrees. So therefore, I also know that I'm 30 degrees short. So it all relates. So 30 degrees is the same thing as pi over 6. All right, and my rotation here to here, well, that's 150 degrees, which is 5 pi over 6. You have to eventually get to a point that the Radians and the degrees are something you're comfortable enough switching back and forth. Now, when drawing angles, the radians are actually easier because you don't have to deal with the measurements in degrees. Radians are a little bit easier to identify as we move forward. But in the very beginning, right now, it might be a little bit difficult. Okay, next example. Here we want to figure out positive and negative coterminal angles of the following. All right, so we're at negative 225 degrees. All right, so that means then, again, negative means that I am rotating in a negative fashion. I'm coming this way. All right, so then that means this is 0 degrees. This is negative 90 degrees. This is negative 180 degrees. This is negative 270 degrees. And then get all the way back around, that's negative 360. Well, I'm at negative 225, so then that means I'm going to rotate down through here, come past 180, and then 225 would be 45 degrees more than 180. So then that means I would draw, or at least try to draw, a 45-degree angle from there. So this right here is negative 225 degrees, this angle that we've rotated through. What we mean by coterminal is that we want the degree measures, or we want other angles that have the same terminal side. So if I decide to rotate, instead of going negative from here and go to here, then that's a different angle. And it's coterminal because it has the same terminal side. So that's what we mean by terminal and coterminal. All right, so then if I went negative 225 degrees and a full rotation is 360, I take 360, because that would be the full revolution, minus the 225, which then gives me an angle of 135 degrees. So there is a positive coterminal angle for theta, and it's 135 degrees. Now I need to have a negative coterminal angle. So the difference between, well, obviously there's many differences between triangle angles and the ones that we're talking about here with rotations, okay? If you have a dog, I mean, I don't know about your dog, but my dogs, they'll rotate or they'll spin around a bunch of times before they finally sit down. All right, or then, you know, my dog likes to do this about 3 times, spin around, go the other way 3 times. So if you have dogs, you understand, they just keep going in circles. Well, that's kind of what we're talking about here. So instead of me going straight to this coterminal side and stopping, I'm going to continue my rotation and go all the way around again. So that means then I've gone negative 225 degrees, and I've also gone an additional negative 360 degrees. So now I'm looking at an angle of 1 full revolution, which is negative 360, and then I go the rest of it to get to negative 225. So that's negative 585 degrees. So that's what we mean by coterminal angles. We're just drawing the angles that go to the exact same spot. Okay. Now if we look at it in terms of radians, okay, well, pi over 4. We know pi over 4 is the equivalent of 45 degrees. So I'm going to draw that right here. And again, thankfully, this is just a sketch. So we're going from here to here. And this is pi divided by 4 radians. Now, if I go through and draw out where we are, so then that means this would be pi over 2. This would just be pi. This is 3 pi divided by 2. And then here's 0, of course, and 2 pi. So now I have to figure out 2 other angles, but if they're given to me in radians, I need to give them back as radians. So now I'm going to go this way, and I'm going to rotate around and come back through, and here's my negative. All right, so a coterminal angle to pi over 4. Well, let's think about this. 1 full revolution is 2 pi. All right, 2 pi, I'll just draw it here, 2 pi is the same as 8 pi over 4. Well, I'm rotating through, and I am pi over 4 short of a full revolution, which would be 2 pi. So therefore, if 8 pi over 4 is a full revolution, and I'm short pi over 4, then that means that this red angle that I've drawn is negative 7 pi divided by 4. So now there's my negative coterminal angle. Now I have to figure out a positive coterminal angle. So positive coterminal, then I'm going to have to go all the way around once and come back to where I started. Now I say once, but I could have done it a bunch of times. I could have gone around 6 times and then brought you the angle, but that's just like overkill. There's no reason for that. So now if I'm looking for a positive, I've gone all the way around once. So that's 2 pi plus another pi over 4. So that means we've gone 8 pi over 4, because that's the same as 2 pi, and another pi over 4. So then that means if I add those together, that I'm going to end up at 9 pi divided by 4. So again, coterminal angles just means that I have an angle drawn and I rotate until I get to the same terminal side. Going to the same terminal side then just makes it so that those are called coterminal. And I can keep going around in circles either direction, but the whole idea is that I end up in the same spot. And again, like I said before, just like your dogs, they know which way they want to face by the time they sit down, but they for some reason want to go around 2-3 times, then turn around the other way, go 2-3 times before they sit where they eventually would have sat anyway. So they still face the same direction, it's just they've decided to rotate a couple times before they got there. All right, so hopefully this was helpful. Again, my name is Robert Main, Charahoe Regional High School math teacher, and hopefully this was a little better in the explanation of what angles drawn in standard form are and coterminal angles. And hopefully if this was useful, go ahead and subscribe to our channel here at Charahoe High School. Thank you and have a great rest of your day.